Good evening, everyone. It's good to see you again. My dears, seventh grade students and pre-algebra students or basic math students. Today, we're going to continue with a lesson according to the rational expressions. Remember in the last class, we were talking about according to the divisibility rules. Well, actually, as soon as you can read in the whiteboard, we explained already when a number can be divided by 2, by 3, by 5, and by 7. Just a little review. Remember, a number can be divided by 2 if and only if it ends in 0 or even number. Number can be divided by 3 when it's a multiple 3 or the addition of their digits gave us a multiple of the number 3 or divisible by 3. Number can be divided by 5 if and only if it ends at 0 or in 0 or 5. And finally, a number can be divided by 7 when we have a multiple 7 or when we're going to discard the units, I mean the last digit of the numbers, and we must double. And remember, we must subtract the leftover numbers with the double the units. And if we have 0 or a multiple 7, that number means it will be useful to divide it by 7. With more details for the explanation of this rule, please check the last video whose name is divisibility rules. Today, what we're going to learn? Today, we're going to learn how to apply those rules at the moment to simplify the fractions. But before to simplify the fractions, the first thing that we must do is learning how we're going to apply that rules these rules into to simplify the numbers. For example, if we asking for simplify, okay, we must simplify the number. For example, we got the number 48, and we must simplify the number by the factors. The first thing that we must do is identify the number. We have the number 48. Because the number 8 is even number, that means we can divide it by 2. And also 48, if you add 4 plus 8, that will be 12, and 12 is a multiple 3. For that reason, 48 can be divided by 3 also. But remember, every time that we have a number whose can be divisible by 2, 3, 5, and 7, always will be going to take a reference, the number 2 or the first rule, because we must follow the orders of the numbers at the moment we're going to start counting, okay? So for that reason, even though it can be divided by 3, this section, remember the number 2 is first, then the number 3. For that reason, we can divide this expression by 2. 48 divided by 2 will be 24. Also, 24 ends odd number. We can continue divided by 2 also. That will be 12. Half of 12, 6. Half 6, 3. And because 3 is a multiple 3, and prime number can be divided by 3, and that's it. We are simplifying this expression. At the moment we're going to write this answer, the only thing that we have to do is count the frequency that the elements of the numbers are repeat. For example, in this situation, the number to repeat 1, 2, 3, 4, 4 times. So let's going to write 2 at the 4 power. That means the number to repeat 4 times, and that results multiply by the number 3 once. And that's it. We're going to obtain the result to simplify the number 48. Well, let's going to start with another situation. One other number. For example, we got the number 405. Okay, 405. Let's review the rules. Because the number, there is no 0 or even number at the end, I mean in the units, we're going to discard the rule number 2. So immediately we can conclude that number 405 can be divided by 5 because the rule number 3 established every number can be divided by 5 if and only if it ends at 0 or in number 5. But basically, before to apply the rule number 3, let's check if this number 405 accomplished the rule number 2, number divided by 3. How we can do that? Simple. Let's check adding the 3 digits. 4 plus 0 plus 5, that will be 9. Okay, and 9 is a multiple 3. For that reason, this element can be divided by 3 at the beginning, then 5. Because in the principal counting, the number 3 always will be first, then the number 5. So let's going to start with number 3, and we can divide 405 divided by 3. And you know, 405 divided by 3, in this case, will be 135. 135. And let's still continue if you were doing well or not, divided by 3. 1 plus 3 is 4 plus 5. That will be 9. So what does that mean? That means we can continue dividing this expression by 3 because the addition of the digits gave us a multiple 3. Well, 135 divided by 3, that will be 45. The number 45 it still will be a multiple 3 because if you add 4 plus 5, again gave us the number 9, and 9 is a multiple 3, so we can continue with number 3, and 45 divided by 3 will be 15. And 15 can be divided by 3 also because it's a multiple 3, gave us number 5, and 5 divided by 5 will be 1. Okay? And for that reason, at the moment, we can simplify these fractions. Okay, we have 3 at the 4 power, okay, multiplying by 5, okay? And this is going to be the solution set at the moment we must to simplify the fractions. And we can continue with numbers so on. Okay, but why is so important? Why is so important to know how to simplify the fractions? I mean, first settle the numbers, and after that, the fractions. Because remember, the fractions can be adding, subtracting, multiplying, and dividing fractions with the same and different denominator. Well, and at the moment we're going to obtain results, it's so necessary to simplify the fraction as soon as we can. But to performing the addition and subtraction of fractions to different denominator is strongly necessary to know how to calculate the greatest common factor and the least common factor. To calculate that one is so important to simplify the numbers in their factors using the rules of the divisibility. So let's going to check another example. Let me copy the instruction. If I said in the problem number 1, find the greatest common factor of the numbers. We can use 80, 100, 160, 264. Okay, we got the numbers 80, 100, 160, and 264. Okay, the greatest common factor, semantic speaking, is useful to simplify numerical expressions. How are we going to proceed to calculate the greatest common factor? The greatest common factor, we have 2 golden rules to obtain that result. The first rule, remember, make sure the factor simplify for any number that must be present in the quantity of numbers that we're supposed to simplify. I mean, we have 4 numbers. The factors will be present in 80, 160, 160, 264. That will be the rule number 1. And the rule number 2, when that's supposed to be present, we're going to take the frequency of these factors who repeat in the smallest frequency. So I'm speaking the smallest frequency, we're going to take the number who gave us the greatest common factor. Okay, sounds simple. Let's going to try it out. Well, first of all, we must simplify every number separately. I mean, we got the number 80. Let's start again. And because the number 80 ends at 0, remember, we can apply the rule number 1. Half of 80, 40. 40 can still divide it by 2. That will be 20. 20 divided by 2 will be 10. 10 divided by 2 will be 5. And 5 divided by 5 will be 1. Okay, simple. And let's going to summarize this expression. How many times the number 2 is repeat? Repeat 4 times, okay? 2 at the 4 power multiplying by 5. We got the factors of the number 80, okay? Now, the number 100. Let's continue. Have a 100, 50. Have a 50, 25. And 25 can be divided by 5, but not by 3, because if you add 2 plus 5 is 7, and 7, this is not a multiple 3. So for that reason, we can divide this expression by 5, because the rule number 3 mentioned, the number can be divided by 5, is the last digit is 0 or 5, okay? 25 divided by 5 will be 5, and 5 divided by 5 will be 1, okay? So at the moment, we're going to simplify these expressions. We got 2 at the, 2 at the 2 power, because it's repeat twice, multiplying by 5, repeat at the second power, because it's repeat twice. Okay, if you see, we know how to simplify the numbers by their factors, applying the rules of the divisibility. There is no way, this is not a random process, how you can simplify these numbers. Well, there's rules of divisibility. You're following those rules, you're never going to have any problems on any issues. Another example, okay, we have the number 160. And this 160, we 160, we can divide it by 2 also, because the rule number 1 says number can be divided by 2 when the last digit is 0 or even number. That will be 80. 80 divided by 2 is 40. 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. 5 divided by 5 will be 1. Okay, let's see how many times the number 2 is repeat. Okay, 1, 2, 3, 4, 5. 2 at the 5th power, okay, because it repeats 5 times, and multiplying by the number 5 would repeat once. And finally, we got the number 264. And because the number 264 ends in the or even number, so can be divided by 2 also. Well, 264, that will be 1, 3, 2. When we have the 3 even numbers, it's simple to calculate the half, only do it by separately. Have a 2, 1, have a 6, 3, have a 4, 2. 132. Now, half of 132. The half of 132 in this case will be 66. Okay, 66. 66 can be divided by 2 also. That will be 33. And the number 33 can be divided by 3, because obviously if you add 3 plus 3, that will be 6, and multiple 3. That will be 11, and 11 is a prime number, so the answer will be 1. So the factors for this number will be 2 at the third power times 3 times 11. Okay, we have the factorization, all of these terms. Now is the moment of truth. There's the moment of truth. Calculate the greatest common factor. Greatest common factor can be written by G, C, F. Greatest common factor. Remember, rule number one, the factors that's supposed to appear in the wall, all of these numbers simplified already. And that rule number one. And rule number two, we're going to take the number whose repeat at the smallest frequency. As soon as you can see, my dear students, we got the number 2 at the fourth power over here, 2 at the second power over here, 2 at the fifth power over here, 2 at the third power. So the number 2 appears in the four numbers, I mean, in the factors of 80, 100, 160, and 264. Okay. And well, we're going to write the number 2. But the frequency, I'm going to take the number whose repeat at the smallest frequency. Over here, 4 power, second power, fifth power, and third power. For that reason, the smaller frequency will be at the 2 power. Let's see if we have another number or something else. Okay. And let's see what we got. For example, the number 5 appears as the first factor, and the second one, and the third one. However, there is no number 5 in the last one. For that reason, the number 5 must be discarding in the greatest common factor because we are not, this is not a, appears, I'm speaking, in 264. So the number 5 will be discarded. Well, if you see, we got the number 3 located over here and the number 11 only 264. This is not appears in 80, 100, and 160. For that reason, we're going to discard already. So the greatest common factor will be given by 2 at the second power. That will be 4. And this is going to be the solution set how to calculate the greatest common factor. So how we can calculate the opposite? The opposite, using the same example, if I ask you, calculate the least common denominator. Using the same sample, okay? If I ask you for calculate the least common denominator using the same numbers, in the least common denominator, there's two ways to solve it. Okay, the first way, just like the greatest common factor, simplify all of these numbers by their factors separately, okay? When you're finished in the LCD, least common denominator, okay? In this situation, it doesn't matter if the numbers appears or not. It doesn't appear, sorry, in the whole numbers that we're going to these compounding factors. We want to discard any number. I'm going to take all of them. And if for one singular reason the numbers repeats in the result of the factors, as a matter of speaking, in the least common denominator, we're going to take the number whose repeat at the most frequency. Okay? This is the difference between the greatest common factor and the least common factor. In the least common factor, we're going to take the numbers whose repeat at the most frequency, and we're going to add in the least common factor the rest of the numbers appears or not in the rest of the factors. However, the greatest common factor, the numbers that's supposed to appear in all the factors, and is that the case, we're going to take the number whose repeat at the smallest frequency. For that reason, let's going to start with the number 2. Well, if you see, you're simplifying already 2 to the 4th power, 2 second power, 2 fifth power, 2 third power. Okay, so because it's the greatest frequency, I'm going to take 2 at the fifth power. Now, the number 5. We have 5 once, 2 times, once. Okay, so the greatest frequency, the number 5 will be 5 at the second power. Well, and we want discarding 3 and 11. Times 3 times 11. And solving the least common denominator, let's going to apply the rules of the powers. Remember, 2 at the fifth power, that will be equal 32. Okay, this is 32. This is not 2 times 5 or 5 times 2. Remember, we must multiply 5 times the number 2. I mean, 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. 5 second power, this is not 10, because that means we multiply by 5 twice by himself. I mean, 5 times 5, that will be 25. And to simplify these two numbers, 3 multiplied by 11 will be 33. Okay. And finally, you can multiply the 3 numbers, 32 times 25 times 33. The answer will be 26,400. 26,400, and this is going to be the least common denominator. Okay. Is the solution set? Just to explain you already, the first method to calculate the least common denominator, all right, will be similar to the greatest common factor. Simplify their factors separately and taking the number who's repeat at the most frequency and the rest of the number who doesn't appear in the rest of the factors. This will be the technique number 1 to try to calculate the least common denominator. Okay. Now, I'm going to show you using the same numbers a second way how you can calculate the least common denominator if you don't want to confuse anymore with these numbers. So in the second method, it's so crucial to be careful at the moment to apply the rules, because in the order to apply the rules, we must to simplify the factors. Okay, the first thing that we must do is separated by a horizontal line the numbers in one singular step. I mean, we got the numbers 80, 80, 100, 160, 264. Okay, I'm not subtracting, it's just like I'm getting together the numbers 80, 100, 160, and 264. Instead to perform the operation separately, I'll do it at once. For example, in this situation, 80, 100, 160, 264, the 4 numbers accomplish the rule number 1, divided by 2, because some of them ends at 0 and another one's an even number. So just in case we have a number that cannot be divided by 2, the only thing that I have to do is copy the number and continue with the rest numbers that accomplish with the rules. I'm going to show you as soon as possible in the problem. So let's see it. These numbers can be divided by 2. So all of them divided by 2. That will be 40, 50, 80, and 132. Okay, we got the 3 numbers, and as soon as you can see, they're still completing the rule number 1. For that reason, all of these numbers can be divided by 2. Have 40 is 20, 25, 40, and this case will be 66. If you see, the numbers 20, 40, and 66 can still divide it by 2, but the number 25 not. So we must to continue simplifying the expression as long as we can. But what's going to happen? I'm going to divide by 2, 20, 40, and 66. And the number 25, I'm going to copy this expression once again because I won't divide 25 divided by 2. So 10 divided by, 20 divided by 2 will be 10. I'm going to copy 25 without to divide because we're going to obtain a decimal number. Half of 40 will be 20, and half of 66 will be 33. Okay? We can still continue divided by 2, of course. The number 10 and the number 20 accomplish with the rule number 1 also. For that reason, we can continue divided by 2. So half of 10, 5. Copy 25 again. Half of 20 is 10. And we continue copy 33. The numbers we cannot apply by 2, only we copy all of them. And the number 10 can be divided also by 2. Continue. Number 2, we got copy the number 5, copy the number 25, and have divided 10 divided by 2 will be 5, and will be 33. Right, 5, 25, 5, and 33 cannot divide it by 2 anymore. So let's check if those numbers, there's anyone who can divide it by 3. I mean the rule number 2. And obviously, that will, yes, that will be the number 33. All right. For that situation, we can apply number 3. We can copy 5, 25, again 5, and 33 divided by 3 will be 11. So there is no more numbers can be divided by 3. However, we can check if there's another rule that will be the rule number 3, the numbers divided by 5. And obviously 5, 25, and 5 can be divided by 5 also. We can copy the number 5 over here and simplify. 5 divided by 5 will be 1. 25 divided by 5 will be 5. 5 divided by 5 will be 1, and 11 cannot be divided by 5. So all the thing that I have to do is copy them. Continue. We have this number 5 again. So divide this expression by 5. We got 1, 1, 1, and the number 11. And you know, 11 is a prime number, can be divided by 11. And the result will be 1, 1, 1, and 1. When we have the entire number 1, that means the problem is over. If you see this time, we made the full process in one singular step. So let's check if we got the same answer or not. First of all, let's go to write the least common denominator, the LCD. You shall see we had directly. You don't need to see what happened individually because all of them has create the least common denominator at once. So LCD will be equal to how many times the number 2 is repeat? 1, 2, 3, 4, 5. Okay. 2 at the 5th power times how many times the number 3 is repeat? Once. Okay. How many times the number 5 is repeat? 1 and 2. 5 second power. And finally, how many times the number 11 repeat? Once. Okay. So let's going to check the answer with the first method. 2 at the 5th power, matching. 5 second power is matching. 3 1 power, matching. And 11 1 power is matching. For that reason, we know already the least common multiple factor will be 26,400. And this is it. This is the full process, how they're going to calculate the greatest common factor and the least common denominator in 2 ways. Okay. Bueno, ahora muchachos es tiempo de la recapitulación en español. Recuerde que las reglas de la divisibilidad son útiles para poder simplificar los números en factores, así como las fracciones. Y esas reglas de la divisibilidad nos van a servir a nosotros para poder eh, calcular el mínimo común múltiplo y el máximo común divisor. ¿Y para qué se usa el máximo común divisor? Simple y sencillamente para reducir cantidades numéricas a una mínima expresión. Parece mentira. Máximo común divisor reduce el mínimo y el mínimo común múltiplo o el mínimo común divisor es el que nos permite maximizar la frecuencia del número. O sea, como que suena un poquito contradictorio. Entonces, con esas reglas de la divisibilidad, podemos calcular el máximo común divisor de estos números: 80, 100, 160 y 264. Lo primero para calcular el máximo común divisor es descomponer los factores por separado, tal como lo ilustramos en la regla anterior, aplicando los divisores entre 2, entre 5, 3, en el orden que lo indica la regla de la divisibilidad. Como usted puede ver, la mitad de 80 es 40, de 40 20, mitad de 10, mitad de 10 5 y 5 dividido en 1, tal como usted lo puede apreciar en lo que son los problemas. Ahora, al momento de proporcionar la respuesta del máximo común divisor, este elige o sigue dos reglas de oro principales. La regla número 1 es que los factores descompuestos de los números originales tienen que estar presentes en toda la expresión matemática, tanto en 80 como 100, 160 y 264. Ese es uno de los requisitos. Y el otro, si está presente en todos de ellos, entonces voy a tomar el número que se repite a la menor frecuencia. Por este caso, tenemos el 2, aquí está la cuarta potencia, el 2 a la segunda potencia, el 2 a la quinta potencia y el 2 a la tercera potencia. Bueno, como está presente el 2 en todos lados, tomamos el de menor frecuencia, que sería 2 a la segunda potencia. Ahora bien, si usted se percata, la respuesta nos dio 4. ¿Pero por qué? Aquí aparece el 5, aquí aparece el 5 dos veces, aquí aparece una vez, pero en 264 el 5 no aparece y por esa razón es un elemento descartable. Ahora veamos el 3. El 3 solo aparece en 200, en el factor de 264 y el 11 también solo en 264. Por esa razón son descartables y el máximo común divisor sería 4. Ahora bien, imaginemos que en vez de pedirnos que encontremos el máximo común divisor, nos pide que calculemos el mínimo común múltiplo, usando esos mismos números. Hay dos estrategias. La estrategia número 1 es comenzar como el máximo común divisor, factorizando cada uno de estos factores por separado, así como lo hicimos anteriormente. En este caso, como les dije, el mínimo común múltiplo es para maximizar las cantidades numéricas. Aquí, en vez de tomar el número que se repite a la menor frecuencia, tomamos el que se repite a la mayor frecuencia. Entonces, miren que está 2 a la 4, 2 a la 2, 2 a la 5 y 2 a la 3. Entonces, el elegido sería 2 a la 5. Y aunque los números no se presenten todos los factores, aquí no somos racistas. En el mínimo común múltiplo no descartamos el resto de los números, sino que lo unimos a la fiesta. Por lo tanto, si tenemos 2 a la 5, tenemos 32, 5 al cuadrado sería 25. Recuerde que aquí el 5 se repite una, aquí se repite una, aquí se repite dos, entonces tomamos el de la mayor frecuencia. El 3 y el 11, como solo aparece una vez, pues ok, lo copiamos y aquí tendríamos el mínimo común múltiplo. Ese es en el método 1. En el método 2, en lugar de separarlos, los unimos todos los números. Esto no es una resta, sino como un guión, como que usted tuviese un lazo entre todos ellos. Y comenzamos a simplificar todos los números en una sola operación, respetando el orden de las reglas. Recuerde que 80, 100, 160 y 264, todos siguen la regla de la mitad. Bueno, como pueden ver, 40, 50, 80, seguimos con la mitad, seguimos con la mitad. Cuando llegamos a este renglón que quedó 5, 25, 10 y 33, los únicos que se podía dividir, perdón, en este renglón de acá, aquí en el tercero, los únicos que se podían dividir entre dos era el 20, 40 y 66. Pero el 25 no, porque se divide entre 5. Entonces, ¿nosotros qué hacemos? Continuamos con los números que aún se puede dividir entre 2 y los que no solamente lo copian. Por eso es que la mitad de 20 es 10, el 25 lo volvimos a copiar, o sea, simplemente ignoramos la orden, el 40, la mitad es 22, la mitad de 66, 33. Claro, 25 se puede dividir entre 5 y 33 entre 3, pero no podemos saltar a la siguiente regla hasta que no terminemos con la regla número 1. Y como 10 y 20 se pueden dividir entre 2, usted sabe, mitad de 10, 5, copiamos el 25, la mitad de 20 es 10, copiamos de nuevo el 33. Y como el 10 se puede dividir entre 2, volvemos a hacer lo mismo. Copiamos 5, copiamos el 25, la mitad de 10 que es 5 y el 33 lo copiamos. Hoy sí, mire, 5, 25, 5 y 33 ya no hay ninguno que se puede dividir entre 2. Por lo tanto, pasamos a la regla número 2. Si hay alguno que se divide entre 3, por supuesto que es el 33. Copiamos 5, 25, 5 y 33 entre 3 da 11. ¿Hay más que se divide entre 3? Por supuesto que no. Entonces pasamos a la regla número 3, los divisores entre 5, que serían 5, 25 y 5, y serían 5 entre 5 es 1, 25 entre 5 es 5, 5 entre 5 es 1 y copiamos el 11. Este 5 aún se puede dividir entre 5, entonces nos queda triple 1 y el 11. Y como el 11 es un número primo, recuerden que los números primos son los que son divisibles por sí mismo y por la unidad. Por ende, al dividir 11 entre 11 nos queda 1 y al quedarnos todo triple 1, terminaríamos el problema. Entonces, al ver, aquí tenemos una sola descomposición de factores. Usted no tiene que estarse preocupando si va a buscar, que en alguno está en mayor, otro está en menor frecuencia, sino que todos juntan una sola operación matemática, en el cual, mire, el número 2 se repite 5 veces, el 3 una vez, el 5 2 veces y el 11 una vez, que prácticamente si lo compara con el rojo, 2 a la 5, 2 a la 5, 5 a la 2, 5 a la 2, 3, 3, 11, 11, la multiplicación de todo eso nos daría 26,400. Bueno, entonces eso realmente ha sido por hoy. Espero, mis estimados jóvenes, estas reglas de la divisibilidad les haya servido a usted como una base, una guía para poder aprender a simplificar los números de sus factores y calcular lo que es el máximo común divisor y el mínimo común múltiplo. En el próximo vídeo vamos a enseñar cómo hacer suma, resta, multiplicación y división de fracciones, ya sea con el mismo y diferente denominador. Si le gustó el video, dele like, suscríbase y compartan. Ya saben, mucho gusto con ustedes, Mr. Buto. Dios los bendiga, los guarde y los cuide. Los veremos en una próxima edición. Bendiciones.